The random forest algorithm forms part of a family of ensemble machine learning algorithms and is a popular variation of bagged decision trees. It also comes implemented in the OpenCV library. In this tutorial, you will learn how to apply OpenCV's random forest algorithm for image classification, starting with a relatively easier banknote dataset and then testing the algorithm on OpenCV's digits dataset. After completing this tutorial, you will know several of the most important characteristics of the random forest algorithm. How to use the random forest algorithm for image classification in OpenCV. We'll first use the banknote dataset used in this tutorial. The banknote dataset is a relatively simple dataset, which involves predicting the authenticity of a given banknote. The dataset contains 1,372 rows, with each row representing a feature vector comprising 4 different measures extracted from a banknote photograph, plus its corresponding class label, authentic or not. The values in each feature vector correspond to the following: variance of wavelet transformed image, continuous; skewness of wavelet transformed image, continuous; kurtosis of wavelet transformed image, continuous; entropy of image, continuous; class label, integer. The dataset may be downloaded from the UCI machine learning repository. The OpenCV library implements the rtrees create function in the ML module, which will allow us to create an empty decision tree. All the trees in the forest will be trained with the same parameter values, albeit on different subsets of the training dataset. The default parameter values can be customized, but let's first work with the default implementation. We will return to customizing these parameter values shortly in the next section. We find that we already managed to obtain a high accuracy of around 96.73% using the default implementation of the random forest algorithm on the banknote dataset. Digits case study. Now, consider applying the random forest to images from OpenCV's digits dataset. The digits dataset is still relatively simple. However, the feature vectors that we will be extracting from its images using the hog method will have higher dimensionality, 81 features, than those in the banknote dataset. For this reason, we can consider the digits dataset to be relatively more challenging to work with than the banknote dataset. We will first investigate how the default implementation of the random forest algorithm copes with higher dimensional data. We find that the default implementation returns an accuracy of 81%. This drop in accuracy from that achieved on the banknote dataset may indicate that the capacity of the default implementation of the model may not be enough to learn the complexity of the higher dimensional data that we are now working with. Let's investigate whether we may obtain an improvement in the accuracy by changing the termination criteria of the training algorithm, which considers the number of trees in the forest, and the estimated performance of the model are measured by an out-of-bag OOB error. The current termination criteria may be found by making use of the getTermCriteria method and set using the setTermCriteria method. When using the latter, the number of trees may be set through the termCriteria max iter parameter, whereas the desired accuracy may be specified using the termCriteria EPS parameter, the maximum possible depth that each tree in the forest can attain. The current depth may be found using the getMaxDepth method and set using the setMaxDepth method. The specified tree depth may not be reached if any of the above termination criteria is met first. When tweaking the above parameters, keep in mind that while increasing the number of trees can increase the model's capacity to capture more intricate detail in the training data, it will also increase the prediction time linearly and can make the model more susceptible to overfitting. Hence, tweak the parameters judiciously. If we add in the following lines following the creation of an empty decision tree, we may find the default values of the tree depth as well as the termination criteria. In this manner, we can see that, by default, each tree in the forest has a depth, or number of levels, equal to 5, while the number of trees and desired accuracy are set to 50 and 0.1, respectively. The first value returned by the getTermCriteria method refers to the type of termination criteria under consideration, where a value of 3 specifies termination based on both termCriteria max iter and termCriteria EPS.